Hey, Kevin. Do you want to just test your ability to share your screen?
Uh, Hi, good morning, Boppy. Sure, absolutely.
It's just you on the agenda, so
Am I the only thing on the agenda?
yep.
How exciting.
I knew you would be. Awesome. Thanks.
Can you see?
Yep.
Great.
The only reason Brian's here is because we threatened him if he didn't show up.
I'm really excited.
We can wait.
Sure.
Oh yeah, we got a decent turnout, but we'll wait till around 8:03 or 8:04.
Sounds good.
While we're waiting, does anybody have any opens?
Hi, Dappy. And Kevin, the presentation would be available somewhere?
Sure, I'd be happy to. Um, how do I do that, Boppy? I just sent to you and then
Yeah, I think we'll send it out one-on-one, but I've not been paying attention to the web page for a while, but we'll push it back to the wiki.
all right, I will send it to Boppy and it'll be available from him. How's that? It's
Great, thanks.
I mean, you've been in the Bo Workstream meeting, so I don't think there's anything new. Super new.
Sure.
Um,
Hey, Bill, did you want to say anything? Okay, so while we're waiting, next week, I'll send out an email because we have a whole bunch of people. Next week, I wanted to do for lack of a better phrase, a debrief on the global summit. One, basically go through our experience center, figure out what went right, what we'd like to change, and then through the session as well. So if you can, if you have any thoughts, I'll send out an email. Please, would you please prepare some thoughts that you'd like to what you like, what you want changed at the either a workshop or the or the experience center. So basically, that would be anybody who spoke and anybody who had a booth. If you want to, it's optional, but if you want to make a slide or if you want 5 minutes to speak about it, next week's your opportunity. And Quinn will cover the we'll cover the die to die 5 workshop as well.
Okay.
All right. Today's speaker is Kevin from Elian. He is going to talk about a proposal for a memory interface. And our plan after this, so today's talk, just to be clear, is not a solution. It's a scoping proposal because the work will happen in the bunch of wires and link layer meetings. So there's a scoping proposal to invite more of you if you'd like to participate to join those meetings. Kevin, all yours. Thank you for doing this talk.
Thank you, Boppy. And for inviting me, and happy to be here. I will go back to sharing since we moved to this as the topic. Can you see my screen okay, Boppy? Either you're muted or
yes, I was struggling to
okay,
unmute,
good.
but yes.
Okay, good. So as Boppy said, this was a proposal And here we have a proposal to standardize work through ODSA, and we're bringing it to this group. And we expect the work to be done largely in the Bo Workstream meetings and the Linklayer Workstream meetings, although it may touch others. This all stems out of a presentation that Elion CEO Ramin Farj had made during the Thursday ODSA session, also as well was in the DIE workshop on Monday, but that's a pretty small audience, on about what we call universal memory chiplet interface. The idea is taking die-to-dies and interface, making them a little bit more memory friendly or memory centric. So I'm going to just touch on a couple of slides that are background to that. I just have a few slides here today, so not overwhelm you with slideware, but a little bit of background, and then describe the standardization scope that was developed, and a little bit of maybe background on that, maybe to help explain it, and then hopefully feel free to interject with any questions anytime. But I'll close again back on the scope, and we can talk about what it is, how we got there. So for a universal memory interface, what we mean by that is we're looking to try to disaggregate the memory interfaces from CPUs, GPUs, controllers. And the idea in a nutshell is that an ASIC could be designed with memory interface, and a later decision could be made on which memory chiplets to use to connect, to either decide to create a SKU that's using maybe a high capacity DDR or a very fast GDR or a low power LPDDR, or even something like an HBM, which is different because the chiplet is would be a base die, but it is similar in concept, and this is where our work initially started. The benefits of doing something like that is, again, you can create multiple SKUs out of a single ASIC, and you can move the, say, DDR interfaces off of the most advanced generation, put them on a N+1 or N+2 generation, and allow you to reuse memory chiplets and connect them to an ASIC. The die-to-die interfaces can be used for this right now. Bo can be used for this. UCI can be used for this. But die-to-die interfaces are inherently symmetric, and memory traffic is inherently asymmetric between read and write. So it is our assertion, and something we've talked about with people, that creating some memory specific or memory enhancements to die-to-die interfaces to make them more memory friendly could be something that would be useful in this context, that would better enable this over just straight using Bo as it's defined today, for example. So that's background. So we took this up in the Bo workstream. We've had a couple of back and forth discussions with a number of people, some of which are on this call today. And as any group, I think there are a lot of different ideas about what one could do in this space, which is great. And the first thing that was raised was really to try to identify what kind of problem you're solving, what are the system level use cases. So that's the first part of the scope that we want to address in the standardization. And in these early discussions, I would say, I don't know how to describe it best, but there's like two types of use cases, groups of use cases have emerged that have some differences, and they are more of what the picture I showed, which has a memory controller off on the chiplet, and what you're really doing is extending the NOC across the chiplet boundary to the chiplet, And in the words of one of the people in the committee, it's more of a AXI-like situation. There are other protocols that could be run, of course, but if you think of it as that, that is one set of use cases. Another set of use cases is more direct memory attach, which is in this example here, I'm saying it's more DFI-like, if you know what that means. But that is more of a memory interface attachment. Because of these two system level use cases that we have discussed so far, and we haven't made any, decisions, but the scope would be to try to drill down on that and see if we have alignment on those. It's possible the scope would then be to look at 5 changes to address the system level use cases. And I say 5 proposal. I should have wrote 5 proposals in parentheses, because it's possible these are 2 different, in my mind, they would be 2 different types of cases, and I'll explain why I say that. But of the 5 proposals, then you want to look at link layers that would go along with the PHY. And that's why we're talking about link layer as well as PHY layers. And then it was Bobby's idea we added here, and I don't know that this is a general usage of this terminology within ODSA, but some kind of configuration that talks about even if the PHY had no changes from Bo, the way you configure it and the way you use it with a link layer in order to address a memory use case could be documented somehow in a higher level document that ties together multiple elements, which today are just separate specs. So this is high level scope. I have some more detail on both of them. The 2 use cases that I wanted to describe, and I think I see that there's a chat. So is there somebody who has a question?
No, just a comment. Keep going. Thank you.
Okay. I'm happy to take interrupt at any time, but what I'll do is I'll go through the next couple slides. There's only 2 or 3 more, and to explain what I mean by these 2 sort of use cases. So this is a case of a DDR chiplet. The top shows a traditional design. The bottom shows a memory chiplet-based design. It's been pointed out in the discussions we've had so far that people are actually building this right now, obviously, because things like UCIe and Bo require symmetric lanes, transmit and receive, or think of it as write and read paths. And because memory traffic is asymmetric, one of the 5 proposals is not so much a change at any level, circuit level, but at configuration change, allowing an asymmetric PHY and enabling it with a link layer that supports it, that has, let's say, half the write bandwidth as it does read bandwidth, in order to make a more efficient memory chiplet interface. So that is a proposal that was made. It wasn't mine. I'm just trying to articulate as best I can as one idea under this umbrella of this standardizing memory chiplet interface that the team could pursue. So that's one. And the second is this one here, which is what was this slide, I think, was shown in the ODSA talk Ramin gave. On the left is an HBM by today, requires interposers in advanced packaging, and it works, well to use in high performance AI compute. But there is a desire by many companies to build lower cost inference that would require, or would not require, an interposer for the compute part, could use just standard organic substrates. It needs the HBM to somehow be a standard package HBM. And there are many advantages that could come from such a configuration. And the proposal that we had made, and in this vein, was to use some kind of die-to-die interface for that. But for a die-to-die interface to directly replace a memory interface, as it would be in this case, from a ASIC standpoint, requires a bidirectional interface. And I created this handy little terminology slide. This is my terminology. I'm not proposing this as universal or anything, but on the left, I'm showing fixed unidirectional links. This is what UCIe does. This is what kind of Bo originally conceived of. You have transmit lanes and receive lanes. Bo 2.0 took that a step further, and you are allowed to put bidirectional lanes underneath each bump, which you can configure at initialization to be transmit or receive. But once in that way, you can connect to anybody else's Bo interface, not knowing in advance how they have ordered their transmit and receive lanes. It's very convenient. We do this already now at Elion. But they're configured at initialization. They're not, even though they're bidirectional lanes, they're not changing during operation. What we're proposing is to add dynamic bidirectional capability to Bo, which, as you can see, is a relatively modest addition to the PHY spec. And that's what all memory PHYs do today. They're bidirectional transceivers that are sometimes transmit, let's say sometimes they're write traffic, and sometimes they're receive or read traffic on the same pin, on the same bus. And that gives you much more efficient memory traffic utilization. It doesn't give you higher aggregate bandwidth than this case, but it gives you higher read or write bandwidth, because you can turn all the pins around one direction or the other, all the DQ pins. And forever, all memory interfaces are built this way. So adding that capability to Bo seems like a good idea. And this last column, which I'm just ignoring for the time, for this purpose of this talk, simultaneous bidirectional, which is both directions at the same time, transmitting and receiving with echo cancelers and all complicated stuff. That's not what we're talking about. We're not proposing to add that. That's the level of complexity, and the ability to standardize that is a pretty high bar. We're just proposing to add dynamic bidirectional, which would allow you to build a chip-to-chip die-to-die interface that works directly attaching to memory. And we think it's a pretty modest addition to the spec. At a high level, the kind of requirements you would need in order to get very high beachfront bandwidth, 2 terabytes per second, which is what HBM needs. And you have to support that in a relatively fixed size, because the interface needs to fit in less than 10 millimeters, the size of the device. You have to have low power, and you have to have a dynamic link functionality with fast bus turnaround. I'm not sure what number this needs to be, but this is something we would be talking about, and that's the key to enabling this change to the spec, is how fast to turn around and what's the mechanism to control that turnaround. But again, all memory PHYs do this, so I think it's a relatively straightforward addition. It doesn't change IMAS or receive or transmit jitter specs or anything like that. So I think from talking with Elon and others, it would be a pretty straightforward addition to the spec. And this is not tied to any specific medium, although we were talking about standard package. It could be advanced packaging or any other thing that we want with that kind of an addition to the spec. So I'll just close, and happy to take questions, but just reiterating again, what in the workstream we came up with was a proposed scope for this memory chiplet interface standardization effort under ODSA would be first to align on some system level use cases, and then to align on potential PHY proposal or proposal changes and link layer proposals that go with that, and then a configuration document that kind of ties it together to address the use cases. And that's what I have today for a presentation. So happy to take questions.
Thanks, Kevin. There's a lot. Just wanted to offer one
hi, Lud.
small. Just wanted to offer one small clarification. The BOFI spec today technically doesn't require symmetry, so it would be sort of just a configuration thing
Okay.
to choose how many transmit versus receive you need. Yeah, like I said, just small clarification.
No, thanks. I misspoke because it's UCIe does absolutely
Correct.
require it, and
Yep.
Bo, the examples show it, but it's not a requirement. You're right about that.
Right. Yep.
Thank you for clarifying
Exactly.
that.
Yep. Sure thing.
We did promise Kevin some additional scope feedback, since there's a bunch of new attendees that weren't present in the board link layer meetings. I'm hoping you have some thoughts on what this on the proposed work.
Hey, Bapi, this is Andreas. So now that we're out of stealth, we can finally participate in the conversation. I'm sorry it's taken so long. So I think a couple of things. First thing is, what do you think? What do you think about this versus like OMI that IBM was working on a while back?
So I'm a big fan of OMI. I like OMI a lot. OMI is, as you know, kind of the OMI CAPI got merged into the CXL, and although I think IBM continues to move forward, I don't think it's moving forward to my knowledge. Is that true, or do you know?
OMI is this is Alan. I was the technical director.
Oh, hi, Alan. Nice to see you.
Nice to see you again. So OMI and OpenCAPI were folded in. So all of the specs, everything's completely opened up on the OMI, and it's owned by CXL Consortium now. IBM are proceeding with OMI on their next gen technologies. So it still exists. And the only other thing I would add, with these channels, I'm assuming there's going to need to be some sort of error management. So on these channels, and so OMI obviously does have that, being a transceiver based approach, and that there is an end-to-end piece of trying to make the latency as low as possible. So that's a critical aspect that I think sometimes goes overlooked, and how you deal with it when if there is a need for a retry. So to keep that latency down to a minimum. But yeah, OMI is still valid, and I think it will be really worth talking to the IBM guys about this, and they're pretty open. They're very open about it, in fact. So,
but to answer Andreas's question directly, my understanding in my head is this is complementary to OMI. This is the on-package version of the off-package unified memory protocol. So there's going to be some kind of an OMI chiplet, and that still needs a die-to-die interface to talk to the rest of the logic, or so it is some kind of an on-die version, on-package version.
Yeah, the only thing I'd say there is devil's in the detail. I think if we could persuade IBM to maybe partake in the discussion, then they can either say what you're doing is they can fit within that or not. I think there may be some.
Well, and maybe also just to clarify, because I think there are, as Kevin was pointing out, there's sort of two broad usage scenarios where in the usage scenario, you know, I'll use the same terminology, you know, the AXI-like or perhaps AXI, just for sake of simplicity, you know, where there is the memory controller on the other chiplet. I think this does end up looking fairly different from OMI in the sense of, mostly speaking, what we're basically saying is, okay, hey, look, like, if you're going to be taking an AXI port on your SoC and the expectation is that it goes off to memory, here's kind of the standardized configuration that one should use, both physically and from a link layer and et cetera perspective. And you know, the fact that it's memory is only really driving that, you know, the particular configuration you use, but otherwise is somewhat transparent to how the data would normally be built. There's the other parallel path where, yeah, that one is much more intimately involved with how the memory works, and yeah, that I suspect there will be much more overlap with or not overlap, but you know, similarities with OMI.
Yeah.
Does that make sense? Or
Yeah, totally makes sense to me. Yeah.
One question, Kevin. Any idea on how much it would make the chiplet interface heavier or burden on the size and power, etc.? Because it's a general addition to.
So you're talking again about the DFI-like case. So how much would the addition of a dynamic bidirectional be to power?
Right, exactly. What is I'm sure since you had a test chip, I guess, or any
Right. So
idea?
my answer is no. I don't have a direct answer, but from a area standpoint, if you're already building bidirectional links, there's very little to almost no overhead. And from a power standpoint, you obviously turn off the stuff you're not using. So at a macro level, there's no big power hit, but because of, you know, whenever you're transitioning the bus, then you've got both everything on as you're turning it around. So there's some very small, I would say, probably power overhead. The bigger issue is performance, and how fast you can turn the bus around will really determine how much performance loss you have from a bidirectional bus that gets turned around versus fixed unidirectional links that are always available. That's really the key thing that I think would need some study.
right, yeah, maybe just to state it in a slightly different way, I think if you try and turn around too fast, then you know the other parameters that you're worried about or asking about in terms of, you know, power, overhead, blah blah blah, will sort of start probably becoming fairly painful. And as long as you make the bus turn around reasonable, quote unquote, obviously the question is what's reasonable. Then yeah, I think what Kevin is describing is exactly the right thing. Saying yeah, it wouldn't have much overhead versus something that otherwise was configurable directionality. And then the question, of course, is just what's the right bus turnaround, you know, time that you spec.
Right. I agree.
And on that note, can you go to the slide that you had some requirements and 5 nanosecond was in there?
Yeah, I did say 5 nanoseconds. This slide.
Yeah. So can you really? I'm not familiar with all these memory standards properly. So what is how does it fit in various latest generation of, you know, memory standards?
So memory standards typically are specified in clock cycles, but if you look at them today, because they're all strobe based and not clock based, they all have preambles and postambles. So the turnarounds are all multiple clock cycles. But I would guess they're in single digit nanoseconds, probably less than this, but they're not in, you know, sub nanoseconds or something.
So overall performance and memory bandwidth a little bit interacts with how this is set.
Yep.
And how power is balanced.
Correct.
Thanks.
I would envision, I've done a lot of memory design and I've done designs of some die links. A clock-based interface should be faster and easier to turn around. You don't have to do strobes and stuff like that to preambles to get things going. But you don't want to push it too hard, otherwise you end up with, as Elad said, your power really becomes an issue. At the extreme, you just leave everything on all the time, and then your powers would be terrible. So you can't do that.
So Kevin, really probably dumb question. So this would completely replace the HBM5?
In this example, yes.
Okay.
It's a proposal we had made at JEDEC to consider standardizing in HBM5. It's not, when you say, I want to be clear that you say replace, it'd be a different product, right? So JEDEC has a HBM5 right now, and this would be ability to talk to an HBM that over a standard packaging, which you can't do today.
Right,
From
yeah.
memory vendor standpoint, it's a different product, it's a different SKU. They would have both, so it doesn't replace it like you do one instead of the other. It replaces it, and that it's in the sense of it's a different product. Like LPDDR is a different product than DDR. They have different files.
Sure, yeah. No, I think I get what you're saying. I think the advantage you guys are proposing is really that it's standard packaging, so it can reach a far wider audience than
Yeah,
the more expensive. Yeah.
Wait, but just so you're replacing the I know you're replacing the HBM5 in the logic chiplet, but it still exists in the package, right? I mean, unless I'm missing.
yeah. In the example we showed, it does. Boppy, this is a way to make a standard package HBM without JEDEC standardizing a new PHY, because JEDEC standardizing a new PHY is going to take a long time.
Yeah.
Speaking as one who's working on that, eventually, I mean, what we proposed was something Bo-like, but with bidirectionality, and eventually it could be incorporated into the actual buffer die to make it use the same memory stacks and build a different product, and that would be great for Bo to have that ability. But that's down the road.
Okay, so but in our sort of design is, if you wouldn't mind going back to that picture, is to sort of, maybe somebody comes along and says, I don't want HBM, I want to replace it with some other memory. The logic die doesn't change. That's our desire.
The ASIC doesn't have to change.
Right. Okay.
Yep,
So
that's exactly right.
Right. So we're not eliminating the HBM from the design or the package. We're just shifting it away from the logic die.
Right.
And or any memory interface. Sort of that I'm assuming that's the upside of what we're trying.
Right, exactly. Or any memory interface. Any other? So this is the scope that the group had discussed. Any other? Oh, sorry.
I did want to say one thing about the configuration thing. The specific thing I had in mind was that ultimately we would have to develop attached proposals for a specific memory, and that's what I meant by configuration. That you would have to define, like, okay, if I'm going to do HBM, I need this many slices. If I'm going to do a 64-bit LPDDR, I'm going to need this many slices of.
Okay.
That was what I meant. I figured we'd need that, right? Without it, I don't see how we would provide the guidance needed to use this.
Sure. In our last meeting, talking with you and your ideas and Elad and others, I'm not sure exactly what the configuration document means. That is a helpful clarification, but I think it either is per memory or it's per use case, depending upon the use case. So I think but it ties together the changes you may need to make in a link layer to support a PHY, either changes or Elad said maybe just configuration of the existing PHY, but it ties it all together. And
Exactly.
That's, I think, how I envision it. Is there an example of
So-
this that's been done before? So
Everything I'm aware of is under NDA. I'm not aware of an
Oh, okay.
open
I'm
document.
just thinking if there's something that we could use as a template, but we'll leave that for later discussion. But this is the overall scope that was proposed and out of the work stream to bring to this meeting today for discussion. So far it's good feedback. Is there any other
I
feedback?
had a question for Paul. Your comment regarding this CXL OCP. Can you elaborate? I wasn't following that particular document you referenced. If you're still, Paul.
Paul doesn't appear to be online.
Oh,
So looking at the spec, I think at least, not speaking for him, but my takeaway is that the spirit of this idea has been pursued in other parts of the idea of creating some kind of a spec for how two things talk is what I took away from that spec.
thanks.
Yeah, the actual OMI is kind of SerDes based interface, but conceptually the link layer could borrow some aspects from it.
Yeah, I believe IBM open sourced the RTL for an OMI interface.
Yes.
Yes.
And
They open source all of it, even both ends, actually.
yeah, so there is some merit. I mean, there's always merit in my head for an idea of an OMI chiplet that then talks to all the other chiplets in the package.
Yeah. That could
Anything
be an
that
exciting direction.
relates to CXL that inherited some of that, or no?
Yeah, no, it's all of the IP. Everything is owned by CXL Consortium now. We transferred everything.
I mean, or CXL. So you could have an off-package CXL chiplet, not necessarily, but if assuming something is open source, but you could have basically an off-package memory protocol chiplet that would then talk on a die-to-die interface to be sort of the more generic version of the proposal.
Wouldn't this a little bit resemble the UCIe's something similar in some way? Not regarding memory, but
Yeah.
off package, on package.
Yeah, but the CXL alone, but that's like it's not a primary target of what we're trying, right? We're simply trying to abstract memory itself away.
Okay, yeah, thanks. Yeah, that's the big.
I think that's maybe worth. Yeah, that there's. I think the two specific things that we're talking about here are both quite different than, for example, the CXL UCIe, but for different reasons. So I think in the quote unquote DFI, like the primary difference is that it's really intended to be much deeper in the PHY, specifically that you're doing the configurable bidirectionality, right? That's something that's not at all comprehended in sort of the CAE or say I should say not just configurable, the dynamic bidirectionality.
Exactly.
And that's not something that's in neither UCIe nor BO at the moment, right? And so that's sort of a very different thing. And then on the other side, for for sort of the version where there's memory control on the chiplet, the other sort of again big primary difference is that actually two is that you're talking directly to AXI, which obviously ODSA has the spec for the approach that one would take from a link layer perspective for how to do that, and two that you actually potentially could or may indeed really
Eli?
We lost Eli on the cell phone jitters.
Oh dear.
I think we heard this.
I think he was going to say, obviously, the AXI part and the potential to make it asymmetric. read write. Neither of
Yeah,
which
I'm sorry. Did I drop out?
you dropped out. Yeah.
Okay, sorry. Yes, but you hit it. You got it correct, Kevin. It's axis and the fact that we're going to make the slices asymmetric.
And for what is what the axis thing has been in our slides from sort of day zero from 2019, pre anything else showing up.
And there's a lot of potential here for doing, other types of memory as well on that same interface. So I mean, I don't know, you could stick a CXL.mem controller on the other side or whatever too. So in order to add additional configuration options for something that is going into a package like this.
Yeah, absolutely.
So other types of memory and other types of memory controllers. That's basically the summary, right?
Yep.
Right.
All right, I've got a painful comment here as well. So this is the danger of running in stealth and working on things quietly, right? But so we've been working on an interface for a year and a half now called UMI.
Oh dear.
Very unfortunately, we disclosed it back in August. Kind of the stack, what it would look like at the OCP DOE workshop. So we definitely have a name conflict here, and so the spec is done. We're ready to disclose it for comments, and we're about to open source the whole thing. And this is covered by complete RTL implementations and drivers as well, right? So I guess the first request is to everybody, if you want to, I can present it next Friday if anybody's interested, and then for comments. This is what we're doing is more along the lines of axis for chiplets, sort of. It's not specifically talking about one memory device, but how you pass reads, writes around. So I think it's everything we've done with the launch. We've done 4 tape outs with this interface. The chip maker stuff we're doing in emulation all uses this UMI that we call it. It's gonna be hard for me to let that one go. But we're now that we're finally out of stealth, we're ready to open things up. And those of you know me, I'm all for open standards. It was just timing.
You
So
could
let's
add,
go about it, Andres.
you could add a bow in front of it or something.
So yeah, so I mean, so the thing we've layered it, right? So it's PHY agnostic, so it's I really look forward to the comments, and it's not meant to be a 1.0 standard. It's meant to be evolving, and so it's meant to work with both UCIe, AIB, right? Because UCIe streaming, right, raw, but I'm sure people are going to have comments, but this is like I said, look forward to joining the community here finally.
So wait, you want to present next week?
If you guys are open to it, I'd love to.
Okay. Majid doesn't want to hear from you, but we'll overrule him.
That's good. We're friends, Papi, now.
Awesome. Okay, you're on next week, Andreas.
All right, cool.
We can push the OCP the Global Summit sync back by a week. That's not a major issue. Excellent. So we just need a different name. You're thinking. All right,
I mean, I don't know. It's this is not my first name conflict. Apparently, I think I'm not innovative enough on names, but Universal Memory Interface is a really good name, I think. And so we, like I said, we picked it a year and a half ago, and we're gonna have to do a lot of search and replace in our code base to get rid of it.
We can call this the OMI, the OCP Universal Memory Interface.
But anyway, let me first present, right? See what you guys think. I would like, again, standards are only useful if people agree on them, right? So we definitely don't want to be standing here alone.
Sold. Next week it is. Wonderful.
Right.
Any other questions? Alan, I was hoping you would have an opinion.
No, I love it. I think it's a great conversation.
Okay.
My belief is that the only I/O out of a computer, out of a processor of any sort, should be a memory I/O, because the natural language of all software is talking to memory, and then the chiplets turn it into all the different I/O standards. So I would like all chips to just have this one universal memory interface. So I love it.
Here, here.
Paul, there was a question for you from Majid earlier on, and for some reason you weren't on, but you're back on. So maybe Majid, you want to repeat your question for Paul?
Yeah, I just wanted Paul to elaborate on the first comment in this document, CXL, and the link you kind of saw in it. CXL.
Unless-
Go ahead, Majid. I'm listening.
No, I was asked, you put a comment regarding, similarities of the OCP hyperscale CXL tiered memory expander spec. Can you elaborate a little bit what you meant, or?
No, I'm just sharing information. I'm just, in case and people haven't seen it, they should read that and be aware. That's all.
Right, okay. But in what aspect of it you saw similarities, I guess, is in terms of in-package chiplet, or is it sort of off-package? This is what Bapi was kind of mentioning, but it's better to hear it from you.
I'm just sharing information. I don't have any particular comment to make.
Okay, thanks.
Quinn Shahab.
Nothing, thanks.
Nothing for me. I think this is great.
And Bill.
I'm fine.
All right. I'm picking on people who I expect might have an opinion. So if anybody else wants to chime in, now's the time. And we're going to do this in the BO meetings, right? Kevin and Elad.
Bo and possibly Linklayer, but
And the link layer will sort of split dynamically. Oh, thanks, Anu. Yeah, so please join those meetings.
So wait, which meetings? Because I typically don't attend those other ones. So which ones?
The BO meeting on Wednesdays at 9 a.m. and the
Oh, sure.
the
Okay.
link layer meetings on Thursdays at 9 a.m.
So it'll be the same call in both meetings, or
Meaning,
you're gonna
it's the same bridge for both, right?
Yeah. No, what I'm saying is when you say they're gonna talk on Wednesday and Thursday, are they different topics, or are we covering the same
Yeah,
thing?
the topics on Wednesday would be the PHY focused ones, and the topics on Thursday would be the more
Would be the
link
link
layer
layer.
focused stuff.
Got it.
Yeah.
Thanks.
But at least for the first first few weeks, or maybe couple three, I think until we sort out the use cases, it might be a rolling meeting. So we'd have to sort of sort out that seems to be stop number one, clarifying the use cases in entirety.
Yeah, I would agree.
Okay, well, Kevin, thank you so much. I think there's a fairly decent interest in the idea.
Yeah. Thank
And
you.
I'm sorry, go ahead, please.
I just said thank you, everybody.
And so rather than sort of, I will do opens in a subsequent week. And does anybody have any opens? Normally I go around, but if anybody has any opens, otherwise I'll give everybody 10 minutes back until the business call starts. All right, in that case, happy Friday. And for those of you joining the business call, that's in 10 minutes.
Thanks.
Thank you.
Thanks, everyone.
Thank you, everyone.
Well, Bapi, can you hang on maybe?
Sure. This is recorded, right?
All right. Yeah, no, that's fine. I get it. It was just a simple, I pinged you on an email just about how you run the work groups. I don't know
You
if
pinged me on an email. Oh,
yeah, I
you
sent you
sent
an
me an
email
email?
just yesterday or the day before.
Damn, man. Okay, sorry about that. I am like,
Yeah, it was just a quick chat about how you set up the work groups because I'm starting to do that in the HPC group.
no, I
And
don't have anything from you.
oh, really?
Yeah, I'm looking. I don't have anything from, unless you sent it to my, you sent it to the LBL address?
I sent it to the OCP project one.
No, I don't have anything. But that's okay. I mean, at least the last email I received from you is October 16th, it says,
No, that's bizarre. I could swear I sent it to you.
saying you can't make it to the workshop or something. I mean, October 10th, excuse me. Were you saying
No, you're
that's
right. I don't seem to have it in my. Oh well, there we go. So well, that'll be why you didn't reply then.
well, I in all honesty, I've been so far behind. It's not clear. I would have replied even if I.
Anyway, I guess the simple question was is how you run the sub work groups under ODSA, because I'm beginning to set a couple up on the HPC, and I know the way OAI runs it, they have these CLA agreements that everybody has to sign, and I think I've heard that some of your groups are like little NDA groups, so they talk together. So what I wanted to understand was how you ran them and how you managed any of the sort of the IP concerns in those discussions. Is it very formal, or are you just very informal?
Depending on the need. The HBI group wanted to be very formal, so it was a work group into which I didn't have any visibility. They created their own little CLA and went away. But James here runs a CDX 3DK group, and it's as open as the main primary group. So it changes according to the needs of the participants.
Okay. And you're not concerned. Yeah, I guess the concern is that somebody during a discussion, somebody goes away and says, "Oh, that's a good idea," and then has a patent, or they have a patent in the background. I guess that's the reason for these CLAs, right?
So we've had that, and then all we did was we just sort of deleted it from the spec.
Right, but what if somebody doesn't tell you that you're violating their patent, but they're just happily, merrily going along?
Yeah. So for that's a valid. For the most part, we've most of our ideas. There's only one real idea that sort of fell into this. Oh, nobody's tried it before. But most of our ideas in our head are sort of general purpose ideas that we're sort of refining. That it's especially in the bunch of wires link layer. Then the expectation is that most of them aren't patentable.
Okay.
One thing though, I think on that context, Aaron, we have a white paper that we're publishing. So generally, what happened when we start putting into a documentation, before we publish that, we ask people to consent to it, either from individual or from if they represent a company, so they have to get the consent from the company before whatever they're writing in that context to be published. So they need to be consent.
Okay. Right.
Yeah, but
mostly it's documentation, but not on the whatever they talk in discussion. There's nothing concerned that, but mostly what we put in the documentation, that's where we starting to enforce things. If that
no, James, this doesn't solve the problem of where somebody goes off and patents it without telling you about it. So they listen to you and they go away and patent it. So what we're doing is sort of getting good faith certificates from people who are active participants, but I think there is a stealth participant bad behavior problem.
There is. I suspect some individuals that remain nameless, but yeah, I guess that's the concern. You start going down an avenue, discussing it in the group, and then somebody runs off and says that's a good idea. They take it and patent it then, and then.
But the benefits of openness far outweigh.
No, I appreciate that. It's
a valid risk. It is that, but if I look at the protocol that was developed in behind closed doors, Open HBI, it sort of dropped off the radar. You would look at the protocols developed in a bunch of wires. More people are sticky because they can come in, contribute even after.
Yeah. But I guess the HBI one's one approach where everyone signs an agreement. But in this truly open approach, somebody can go away and I guess you can get baseball batted in 5 years' time if it becomes a rip-roaring success. Like, I guess it's the Rambus one is what everyone keeps talking about, right?
Correct. But so far we haven't hit any. I don't think anything we've hit is not stuff that hasn't already been in the public domain for quite a while.
Yeah, and well, the more we record it and everything's written down, at least we know the origins of these things, and if those patents pop up as a result, then yeah. But I guess if they drill down into specific details that you haven't covered in the open forum, then they can set little landmines. That's my concern.
The command license we cover that one, right? I'm still talking about.
No. So James, this covers the people who sign it. It doesn't cover the people who don't sign it.
Right. Exactly. That's my dilemma. I mean, we're just about to kick these off.
But that exists. That effectively exists. So you really don't have one weird corner case where somebody deliberately sneaks an IP that then they go fall silent on and walk away,
right.
and you can pretty much track that behavior fairly easily. They'd have to participate. So if they didn't participate, then it wouldn't make any difference whether this was closed or open.
Right.
Hey, I'm going to end this bridge and start. Oh, it's too late. Okay. Anyway, then it'll be one giant recording.
Oh, sorry. Like that.
I think it will stay, right? Even though you leave, I think it will continue. I think it should be fine.
Yeah, the bridge will stay, but you won't get 2 recordings.
Oh, I see. Okay, makes sense.
Would you also come back on?
No, I think it's fine. We're good.
Just to follow up that, I think I thought when you publish something in command license, then that is already public. Then you cannot patent that anymore, right? Do you still patent that?
No, James, Alan's focused on a very narrow class of bad behavior. Imagine I joined your CDX group and give you an idea, right?
Discussion, not in the writing, not writing in the white paper yet or anything.
In something, I give you an idea, but I have some secret backdoor which makes the idea unworkable with other IP I possess. And then I walk away from the group saying I'm no longer interested, but you guys like the idea and you stick with it. Then the spec contains something that's critically dependent on me.
Got it. I think if that's something is not published or anything like that, yeah.
I guess I don't think that was exactly how I was thinking about it. But I guess I'm not a patent expert, but it's just I mean I don't think you can do anything these days without stepping on somebody's patent.
Yeah.
So.
But I can tell you that the work groups being open, like CDX is to me is sort of a super example of where it's open and all sorts of participants come in and it's fantastic.
And it is I agree. That's why I love doing it, and I don't really want to get embroiled with these damn CLAs and all the rest of it. But yeah, all right.
But after that, James is exactly right. Once you're about to release, you need the consent from every participant.
Right. So, but if you haven't been running a subgroup with a CLA, the participants come and go. How can you get everyone's consent once you publish that white paper?
Well, so in different groups, we deal with it differently. So in CDX group, they actually write a white paper, so you know somebody's submitting content. You have a track record of who submitted what.
Okay.
In the bunch of wires, we have Git check-ins, which pretty much figure out what IP came from where, when it came into the stream, and we pretty much have a clear sense of who contributed that IP.
Okay.
So there are tracking mechanisms which kind of, and in the link layer, what happens is one company basically wrote the whole spec and submitted it much closer to a traditional OCP model.
Okay.
So there are some mechanisms for tracking who did what, and we can establish the lineage of any piece of data.
Okay, so your recommendation would be make it as open as we possibly can, and no paperwork to be signed, but obviously make sure you track the contributions some way or another.
Yes. So we've got recordings, we've got Git check-ins, we've got white paper, white paper submissions, and we've got single company submissions. So, but all in all, there is a strong mechanism to track, strong set of mechanisms. It's not the exact same one, but there are mechanisms to track who contributed what.
Yeah, you've got more like the recording itself in the fact that Zoom tracks the individual attendees' names when
exactly.
Right. Okay, so you got lots of evidence of a particular individual's participation.
Exactly. And then we've gone in reverse and scrubbed stuff once somebody doesn't want it either, because we know exactly what they contributed.
Right. Okay. Okay.
Yeah, I think especially recording poll make people think twice before they try to claim them for themselves. There's a record history there.
Right. All right. No, that's good. Thanks, Pappy. All right. Sorry to derail the start of your business meeting.
My pleasure. But Marek, there's only one recording. We it's a long story, but we didn't log off and log back in.
Oh no, it's totally fine. I guess whenever that happens, I just like put in the email that people should start watching at 1 hour if they just want to see the business group content.
Well, you can use like a video player group to edit that before you send it out.
Oh, do you mean you can edit the link and like put?
No, you probably have to download. You probably download edit on your Rocker computer and then people upload somewhere else to share that. You can.
Oh yeah, I guess so far I'm just using the wherever the videos are currently hosted through Zoom. I think Zoom themselves host it, so I just use that.
Oh, yeah, I think Zoom host can do editing too. I haven't tried that, but I look into their feature on that.
Interesting. Okay, well that's good to know.
Oh, actually, sorry. So you actually just keep it on Zoom, Marek, do you? Is there an OCP policy on? Because I've actually been downloading them and actually copying them into the Google Chrome.
Oh no, that's fine too. No, I guess like I'm just being lazy because there are now with the new Zoom system, there's a link generated after like a recording has occurred, and then I just copy that link into the meeting notes and send it out.
Yeah, in fact, I think we should ask OCP management what the policy should be, because it seems pointless to make multiple copies. I think your idea is the best idea. If OCP is happy to, I guess the Zoom space that gets used is paid for by OCP, so OCP own it.
Right. Yeah. I guess Bobby, do you have any thoughts on how this works?
Wait, sorry, I stepped away and I
yeah, no worries. No, just the basically if it's okay to leverage the fact that these videos right now are recorded on Zoom, or and whether we can bank on the fact that they will be always available there, or whether we should make a copy and put them on Google Drive.
No, they'll be available.
Okay.
I mean, the OCP has recordings that go back like 7 years or something right now. So
yeah. Okay, well then that's easy.
It's not the availability, it's more the indexing and accessibility that's harder.
Right, that's my point. Yeah, that was my point. Whether the indexing will disappear.
So, Bobby, are you still looking for those videos right now?
No, they all exist, but I see. They all exist, but somebody will have to go manually and say, I got this recording was made on Thursday at 9 a.m. So it's likely a link layer meeting, as an example.
Okay, so
they don't come auto-labeled.
Okay,
you have to manually label them.
So someone is working on that right now, labeling them.
No, nobody's working on that right now.
So how can we find that? I mean, can we call?
I mean, there's a list of recordings that I can get to you, but figuring out which ones are yours is an effort of manual labor.
Okay, maybe you can send that to my way. I can try to find out some way there.
Sure, that I can get. I think we can get you.
Okay, appreciate that.
Say again, Rajesh. Okay, maybe this was involuntary. Okay, so then I guess otherwise I was just going to check in with people on the white paper. One important point I guess you guys were discussing before is do we have to do besides making sure that all of the figures are open source, is there anything else we have to consider in terms of CLAs that have been done for a bunch of wires? Do we have to do something similar here, or can we just publish it the way it is?
No, the bar is lower.
Okay.
So a CLA gives away IP rights. A white paper doesn't. So you just have to, there's another kind of a Creative Commons license equivalent thing that you have to sign.
Okay, and you have these things available?
Yeah, so if you go to the OCP webpage, they should have a link to licenses, and that's one of those things that you sign. The CDX guy signed this for one of their earlier white papers.
Gotcha. Okay.
So if it's a white paper, you're not contributing IP, you're just contributing documentation. It's a spec, right. You're also doing an IP release.
Yeah. Okay, then I'll look up that link and then that's but it sounds like it would be
Hang on, let me see let me see if I can
Yeah.
find it. I'll put a link in if I can.
Okay, that'd be great.
Okay, cool. Maybe I can
I'll share my screen in the meantime.
Sorry, guys. I know it's
So Marek, I added some comments on the thing yesterday, made some changes. I wasn't
Yes,
sure.
I saw that. Thank you.
Okay, yeah,
Oh.
because it's weird when I made some changes, it didn't show up the original and then the new, so I wasn't sure what.
So I certainly saw your comments. I saw you like had the document open. I'm not sure if you know specifically where you made changes. I am happy to go there and see if it took hold.
Yeah, no, they seem to be there, and they were all more of syntax or typos. Those
Yeah.
were things I fixed. I didn't make any technical changes anywhere because I
Yeah.
thought it was reasonably good shape.
Let me see if there's kind of a, I'm not sure where the revision control is, but then maybe that way. Okay. So did you check it? Like, did you have any reference point where we could check now whether the things that you added have taken effect?
Oh, sorry, I was talking to the muted phone. Let me just take a look on my side and let you know instead of wasting everybody's time by scrolling.
Okay, I mean, I hope otherwise that I definitely see the comments that you added, so I hope that the other small fixes that you did also went in here. Akash, I saw you also had a chance to work more on your section. Do you want to talk about that a little bit more?
I think I just added the reference, and then there was a question about, the costs that you had. I think that was the bit that I really don't know what to do with, because I was just suggesting that, hey, we should put some costs for what it really takes to take open chiplets and then put them into a package, right? And then I think you had a note, well, we need to get, and I agree, we need to get input from a whole bunch of different people to and figure out whether we want to include it or not, right? So maybe that, from my side, that was the main open right now from, do we even need to put it in there, or what do people think, right?
Yeah, gotcha. I think it's just it's tricky because we're addressing such a broad space, and I think the numbers that you're giving, like, we could probably find a case where you say, like, yep, like in this case it makes sense. And I also ideally like the idea, like, I think it would probably make more sense if we actually had a lot of data and we could give just for, like, say, a small chip design, and then give some numbers like area or like process node. But in this case, yeah, so I guess Anu chimed in and said it was also difficult to quantify. So what do other people think in terms of the question here specifically for this section on giving the reader a sense of, if you had chiplets available and you just wanted to combine them, the scope of that work in terms of man months as well as cost? Is that something like that we should include, even from the perspective of like detail, or like is it valuable? Are the numbers accurate?
Yeah, I think the accuracy might be the issue, right, Marek? It really depends on what you have and what you're combining. But I kind of see Kash's point of, if you have to instantiate a D2D interface, is there a standard amount of time? Is that kind of what you're looking for, Kash? Like, can you say
I was just trying to give people, I'm just trying to give people a range of some idea of what's involved, because I think that I've talked to, a number of people, and, they get all excited about chiplets and Legos and how simple it's going to be, right? And then assuming you have these chiplets that don't exist today that you could put together, what do they have to do, right? I don't think anybody's addressing that. Maybe we, because there really are no good numbers, and I just put numbers in there just, you know, out of my what, right? Just so that we have something. This was meant more for the team to say, hey, you know, in reality, the substrate cost is 100K or it's 800K. I don't know what the numbers are, right? So I have some reference point, but I'm certainly no expert in this at all.
Cash, one thing is we're talking about, like, are we talking about like additional time needed? For example, you have package design. A package design is needed whether you do a monolithic or you do a chiplet, right? Are we talking about like a difference in the amount of time required to do one versus the other?
I guess that you don't really need to do a package design. Let's say that you have chiplets that are available in the open. So the context, I think, was the open chiplet marketplace, right? Or so you are going to buy chiplets from Microchip and Analog Devices and your chip, let's say, right? So, okay. Then what? You have to design a package, right? So what type of package? I mean, there's a whole system design. You have to develop a test program to what's you know, they need to have some idea that this is not a zero cost. That's kind of what I'm trying to get to.
Yeah, no, I understand. It's just difficult to put numbers other than like what you have could be, or we could, you know, buffer that even more because we don't really know.
No, I know. The question is first, do you think it's valuable to people who are, because we have a wide audience, right? We have people who are trying to develop their own chiplets, right? Or implement, thinking of using chiplets for their chip, right? So it would be at a large semiconductor company. And they're doing their own end product and packaging it. So that's great, right? I think we have that covered. The bit that nobody seems to talk about is, you know, there's going to be a cost to deploy open chiplets at scale, right? So I think that's the context here. And I put some numbers in here. So or maybe if we don't have any numbers, we can just add a simple thing saying, just be aware that there will be design, simulation, package design required for an end customer to take chiplets and put this. I mean, maybe that's all we can say, right? So,
right.
So Mark, does that make sense that if we don't have any numbers, then we should just be clear that, hey, there is going to be an additional cost that they need to think through, and I can word that, and then in the next few days and update that, because certainly I don't want my numbers in there. I'm just, you know, using some little knowledge that I have, but it needs to come from the group in terms of, you know, are there numbers, or are there, and that's I think the fundamental problem, because we're so early in this space that, you know, numbers don't exist, and because designs vary so much, the numbers are, as you said, you know, there are going to be designs where this number is going to be 3 to 4 times the number that I put in there, if that makes sense, right? I tried to take a simple design. I tried to sort of say, okay, just for 4 or 6 chips and something simplistic. But even that's difficult, right? To have numbers. Hello?
Did we lose Marek?
I don't know. I was waiting for him to say something, so we may have lost Marek.
Yeah.
Well, then I'll fill the void. Silence is friend. Yeah, listening to this,
I think Marit may be speaking, but
Yeah, like, can you hear me now?
yeah, we
oh,
can.
I
yeah.
think I'm having issues with my audio, like it just like cuts out. Okay, but no, go ahead. Like first, Trent was going to say something. Like, go ahead.
Yeah, yeah, what you were just describing, Cash, and this is something, boy, we're having discussions just about every day internally about this. You know, there's people out there like, for example, Lantronix, and there's other people who are making these modules, right? You know, right, and what they're doing now is they're purchasing packaged parts like from Qualcomm, or you know, there's module makers that are purchasing parts from NXP and other folks, right? And you know, creating these systems, you know, which then they can sell to OEMs or tier ones, right? You know, and that's a different business than what NXP does, for example. You know, so what you just described, Cash, I think is really kind of the next step or extension for these module makers who are integrating packages, right, from different semiconductor companies, and now the next step would be to integrate, you know, chiplets, right, you know, from a chiplet marketplace. You know, for companies like NXP, where we're in the business of designing and selling semiconductor devices, you know, packaging parts, you know, packaging different die or chiplets from other semiconductor companies is not, you know, is not something that would fit our business model, right? The margins just aren't there.
Yeah.
I think there's kind of two ways to look at this, right? And what you know, when I think about the audience for this paper, there's people who are saying, yeah, I want to be this integrator, you know, I'm already in that business. And in that case, it would be, okay, yeah, what's the cost to design this thing, to put it all together? You know, don't worry about the cost to tape out the chiplets, right?
Right.
But when I think about you know, companies like NXP, or you know, companies that would say, okay, well, I want to actually take my current SoCs and start to disaggregate them and make chiplets, and so now I need to consider you know, the sunk cost in taping out these chiplets, and I think that's maybe into what you were alluding to, is it becomes much more complicated, because then you need to look at, okay, what different product lines and business lines can I use this chiplet across? You know, what's the longevity? You know, what kind of legs do these things have? You know, before I'd have to rev them to a new silicon node, and that's much more complex.
Right. Yeah. Right, Trent. That's what I was referring to.
So I guess we just need to decide, you know, for you know, I mean, maybe we could make some type of comment about, okay, you know, if you just want to, if you know, kind of put the qualifier, you know, for a chiplet marketplace type of application where you're purchasing chiplets, you know, this would be what it would take to put them together.
Yeah, no, I agree with that. The question is, should we just give any numbers, or should we just say this is the process that you need to, you know, undertake, right? So because there's to your point, there's people reading this that are designers or managers at a semiconductor company, and this is of no interest to them. And then there may be module makers or end users who are trying to understand how chiplets are going to work, who might be interested in this, right? So I think that's the yeah, maybe what I'll do is I'll take a whack at it in terms of, I'll take the numbers out, but still say, hey, to your point, Trent, that if you're interested in the open chiplet market, where how it's going to work, this is how it's going to work. There will need to be some integration required, obviously, and these are the steps. And then that it could be an integrator doing that. It could be, you know, a smaller company doing that and creating their own product for sale, right? Taking multiple chiplets And it's like HBM, right? You can say HBM is kind of a chiplet, and right, and they're being people are using those to create products. So yeah, so let me. I think that's in light of no numbers, and because there's so much variability, I think it's good to just say, hey, this is the process that somebody needs to do once there is more general availability of chiplets, right? So, point taken. I think that's the right way to do it. I think about it as well.
Yeah, I think that's
Marek,
a good idea.
your comments.
Yeah, no, I think it's a good idea, like to still keep in the information, for example, saying like just because you have chiplets, you still need a substrate, you still need to figure out how to test the entire module, and all of that you can describe verbally. And maybe even for that last bullet, I think we could jump at numbers and say like this could still be like on the order of a year, and could go into like $1 million+ development, dollar development. And I think that like then it's really just kind of giving somebody one reference point. And I think if you say it that way, you wouldn't necessarily claim that all of such engagements would be above $1 million, but it helps people calibrate, like thinking it's like tens of thousands or like hundreds of millions, and to say like it's probably somewhere in between.
Yeah, that's fair. I'll draft I'll redraft this, and then you know, certainly before next week, and you'll have a chance to look at it. And then I think you've said, hey, let's get everything done by the 10th. So I think we should be on schedule for that. So that's good. Okay.
Thank you. Yeah, that was a good discussion to have. So I went through the other sides, like as I said, I've seen some comments from Anu. Maybe for others on the call, has anyone else had a chance to take a look at sections that they have not written and been able to just like basically think a little bit critically about like, does this look good? Is there anything major missing? Or even just down to there were a couple typos and I fixed them.
I did take a read, and I think it looks good. It's just a lot in there. I hope people read it. So that's all.
Marek?
So otherwise, I guess, yes.
So there's one question I've had. So one of the things ARM said in their talk at the Global Summit, which kind of aligns with at least our pitch as well, is that they see the immediate future as being smaller groups of interoperable chiplets, not necessarily a marketplace. Their marketplace is a step after that.
Mm-hmm.
And it's a question, or not even a comment. Should we distinguish between the needs of this immediate first stage versus the needs of an open marketplace?
I think yes, and maybe this would then go back to Kosh, since he has that section. I think it's worth, at least at the beginning, to sketch out that on our like that everyone has this long-term goal of an open chiplet market, but that what we can see right now points towards at first these islands of chiplets that are compatible based on collaboration of a couple of companies. And then I think it's still okay, like depending on how you want to do it, Kosh, to like explain, because I think even with your company, you're probably like you can see that same thing unfolding. And if you have any thoughts on what has to happen right now to just establish partnerships and let's say zones of interoperability versus long term, but I would certainly mention kind of that's the way it unfolds in the long run, because at least I'm also convinced that that's what we're seeing today.
Yeah, I think that's a great point, Bapi and Marek. I think that we definitely need to address that. And also in light of the fact that the standards are changing, right? There's multiple stuff going on. If you just say we're going to stop and wait for everything to be defined and then test the interoperability and then everybody marches to the same drum, that isn't the way it's happening, right? So things are growing more organically. So I will add, I think that's a really good idea. I was thinking of doing that or suggesting that more for either the conclusion or something, but that's I can put it at the start of this and have you guys edit it and feel free to add and make comments and things like that. So I'll do that for sure, because I think that's that is very relevant to end customers, right, who are looking to buy chiplets. Is do they work who do they work with, right? So I think that's that's important. I like the islands of interoperability. I think that's a good way to put it.
Yeah, it gives people kind of an idea of how maybe in the end these islands grow together towards a big continent. Right. But in the meantime, that's not it.
Yeah.
Okay, yeah, well, thanks for that comment, Buffy. That's really helpful. Anyone else who had a chance to look through this, or like, and I, as I said in my email, I'm looking for kind of like final comments by next week. So if you hadn't had the time yet, no problem. I think we have one more week to like look through this, but I appreciate that some people already took the time.
Marek, hi, this is Vishwa from Acronics. So I got a chance to look at the first half of the paper, and it all seems fine. So I didn't get a chance to go through the complete paper, but at least a fresh set of eyes, I think I do understand everything that's being written, and it seems like your target audience is basically product managers. So at least at top level, till section 4, everything seems to be clear.
Okay, great. Thanks for the feedback.
Yep.
Hey, Marek, one more question. Again, it's a question, not a recommendation or is it worth it to mail it out to a couple of people we think might be potential targets?
It's kind of a bit of a beta test.
Yeah. See what their reaction is. Okay, hang on. Let me just mute Rajesh for a second.
Yeah, I think Rajesh is. I can.
Yeah.
Yeah.
You had to. Yeah.
Do you have like people in mind, or like are you thinking about basically for example contributing like from the author list, like if I would send this to somebody else with an ABI, or maybe on somebody else in Microchip, like are you thinking about kind of like connection or like third parties that are not involved at all and may find this interesting? Because then the next question would be who are those names?
Yeah, so I was thinking a mixture of both, but predominantly sort of marketing people amongst our organizations, but at least one person maybe outside. There's one random name I was thinking of, but I'm going to go and check with that. Check with them, but just sort of say, hey, we're going to do this. But basically, there's a couple of people at Microchip who are sort of known skeptics in my mind, and just having them read it and say,
I wonder who you're talking about.
Having them read it, but having somebody in the target audience read it and say, okay, we like this, or here's some changes you should consider, may strengthen the paper if we're up for it.
Yeah, no, that's certainly true. For at least for ADI, I think I could find like one or two people that are already kind of like going or would know something about it and would be more in the like towards the marketing space. So yeah, I could certainly do that. And I think it's a good idea. Like at this point, the more we can get feedback, the like hopefully the more beneficial it will be to the final audience.
Yeah, and the more credibility you'll gain, basically.
Yeah, that's true.
Okay, I will also ask Cliff if he has any. He usually has some clever out-of-the-box ideas, so I'll ask him if he can think of anybody else to review this too.
Or I mean, even I know he's been on a couple of calls in the beginning. If he has time to review it, or if he knows somebody that would be qualified, or even like is a good critical thinker and feedback provider, that would be helpful. Yeah.
Yeah.
And then I guess for the rest of the team, I think that would be if you know anybody that would is either like technically strong and can give feedback on like the accuracy on some of these things, or is more in the kind of like the receiving end of who we were writing this for, and just kind of having some people tell us like, I'm totally lost in section X, I don't know what you're talking about. Like those kinds of comments, I think Bobby has a good point, would help us. Even sometimes it may just like need an extra 1 or 2 sentences to set the scene for why we're talking about a certain thing. But I think we which may be a little bit blind towards some of these very basic questions about why are we structuring it this way, or why are we like discussing these and those items.
Marek, I think I'll fit into the second category.
Yeah,
So
okay, perfect.
I will ask all the dumb questions. Don't worry.
Okay, all right, excellent. Okay, so then let's see if James, you're still on the call. I wanted to see if you had any time in particular to go through the couple of comments I've added, and like, yeah, if you had any time to review your section one more time.
Yes, I'm going through that actually right now. I'm making some of the comments, so I probably going to continue this process. I probably should have something I think I more ready to talk about next week if any more. I'm going to address those comments that you have pretty much.
Okay, perfect. That sounds good.
One thing I have to, one comment I have though, like if we go to bottom for the references, now you kind of section out for every section, right? Are you planning to combine them eventually? Because
the
might be
section here in the appendix, you mean?
All the way to the end, you have the references, the reference section.
Oh yes, yeah, no, definitely combining them into one. I think I just did it. So you're talking about. Let me just show this to everyone. References, yeah. So far, I've just broken them up to the sub chapters because it was a little bit easier, because that's naturally how people added them, just with starting at one for their own section. So I didn't want to mess with that immediately. But yes, in the end, I would go through the entire document and make sure that we have like one set of numbers running from 1 to however many, so that it looks like one cohesive document.
Right. So are you going to do that numbering when you?
Yes, I was just going to go, and I mean, I think for some of these references, that's going to be a little bit of like busy work, just getting them all at least into some kind of standard. Like I'm not sure if I'm going to use like a reference manager or something, but even for the links to at least put in information like when have we accessed the website and so on. So they're like, I think this is basically a placeholder for a more like proper reference list.
Got it. Yeah, makes sense. I just want to make sure we can. Are we no, I think that's good. Yeah.
Okay. Okay, I think, let's see. Oh, and then Alan, since you're on the call, I think for the next steps, I haven't necessarily taken a stab at this. I would probably want to add a little bit more, just to use also this section to round off the discussion we've had, and like things like, for example, like Kash said, like maybe repeat the main points in a short section. So I think when we first talked about the section that you added, it was more about the idea of how chiplets as an intermediate point can serve as a kind of as a for like a prototyping effort. So when I like read through it the last time, I think some of these things may be in more detail than it's useful for kind of a next step section. So I think maybe you would have some of these a little bit more high level, to like rather like basically present this idea of going from like kind of a systems approach to starting to replace sections of a system with chiplets and using emulation for the rest, and just sketching out that idea rather than like talking exactly about how you would do it. Does that make sense?
Right. So you want a short and more succinct description.
Yeah, a little bit like I think specifically the second half. I think the first one is great, and then like taking these bullets and basically describing how you would go about, like, I think it's a very interesting approach. It's also, from what I can tell, different from the way it is done today. And so just talking about that rather, and then maybe if we can get that to half a page in total, then I would have a little bit more space to add things, just kind of like having a summary type of paragraph for the whole document.
Okay, I can look at that. I can. So do you want me to basically is trying to shorten it a little bit and.
Yeah, exactly. Yeah, but like basically that's like.
Yeah.
So if that would fit into, like, I mean, you're already at 3 of the page, so I think there's probably not even all that much. Like maybe taking like 1 or 2 paragraphs out and just like basically compressing this into a little bit, like 70% of the space or so.
Yeah. Okay.
Perfect. Thank you. Does anyone else have thoughts on what we should be doing here, or does this look good to everyone else?
Marek, I just updated my section a little bit.
Okay.
And I added some comments, so
go up. Yeah. Yes, perfect. Okay. Yeah, I saw that. I haven't had a chance to read through it, but that's good to have the definition in here. And that was the only change, or you also did some other smaller changes? Oh, you tidied up the section. Okay. Okay, and then I think last time we had talked about, at least possibly for this figure to, okay, thanks, Anu, to explain that when we talk about substrate testing, to maybe remove the wafer level and just talk about that substrates could be wafers or filter substrates or organic interposers, for example. Do you think you could make that change, Rajesh? I think you're back on mute.
no change from my side, Mark. I think everything is.
Yes, no. I mean, we talked about this last time. At least that was one thought I had when I saw this diagram, to make the substrate test a little bit broader, and because I think the way it reads to me right now is that like substrates, like I would consider like wafer level and substrate to me don't go together in my head, because either if it's wafer level, then it to me is an interposer, and for substrate I think more of the like organic substrates, and to just like generalize it a little bit, because I think we also want to cover spaces where you may not use any silicon interposer or organic interposer based substrate to put things together, and you put them directly onto a laminate of some kind.
Oh, okay, I can. We can talk that offline, then we'll update it.
Okay, Trent, okay. What do you think?
Yeah, I'm fine with that.
Okay. All right. Yeah, then
I did move the table to the appendix. I think that was the only change I made.
Yes, perfect. I saw that. That's great. Thank you. Okay. I think that's all I had to or wanted to touch upon today. So then I would just say, let's meet again next week, and it would be great if whoever didn't have a chance yet to go through the document, just to take the time and basically see if anything doesn't add up to you, and put a comment in there. And then once we have everyone and know that everyone has gone through it, then I think we would also get towards this goal of having it be credible, because I think all of you have good insights on various aspects here of these topics. And and Boone, since I have you called, do you mind sending your email address? I think I have you on the list, but I wasn't able to email you separately. Okay, perfect. Thank you.
I just typed in the chat my email address.
I see it here. Thank you. Okay, then I think we can end this meeting here and just reconvene next Friday at the same time.
All right, sounds good.
Okay.
Thanks
Thanks everyone.
Okay, thank
Yeah.
you.
Bye bye.